Welcome back, everybody. In this video, we want to implement a data structure for problem number 745, prefix and suffix search. In this problem, we should design a data structure such that in order to store a list of words. So this problem consists of two parts. The first part is very easy. So we are given a list of words, and we should somehow store these words into our data structure so that we maximize the efficiency or performance of the second function. And what is the second function? So this is our query that might be run 15,000 times, and the words doesn't change. So in each query, we are asked to find a word that starts with some prefix and ends with the suffix. So for example, here, if we have a single word, apple, for example, in our data structure, given a query, a word starting with A and ends with E, so definitely we have only one word that matches this query. This is apple, and instead of the word itself, we should return the index. So we should, let's ignore that for now. Let's design our data structure so that we first find the words and then after that we return the indices. So what we're gonna do in this case, since this f function or the query function will be called 15,000 times, we should make the time performance of this as good as possible. So for starting of the words, let's say for apple, for example, the example that we have, we want to add apple into our data structure. So we are iterating through all words in this list and then add them to our data structure. So apple has some multiple prefixes. So one empty character, one A, one AP, and so on until the whole word itself. And then let's say we have a dictionary, a very large dictionary, and then for each prefix, we add the word itself, the whole word, into that list of all words that are starting with the same prefix. So let's do that for now. Our always friends is the Defaultdicts, so let's import that from collections, import Defaultdicts. And then we are iterating through the word. First of all, we should initialize self.prefix is equal to a default dict of type set. And then for each word in words, we should first iterate through all characters in this new word. So for j in range of the length of this word, then let's self.prefix of, let's extract a portion of the word itself, which is until index j, that add the whole word. So we are iterating through the characters one by one and then extracting that portion as a prefix of the word and then adding the word to that set of prefixes that is starting with that. So similarly, we need to define another default dictionary as suffixes. As we know that we are iterating through the words, the length of the word itself, starting this way or reversed, is the same. So as we are iterating through all different prefixes that a word has, at the same time, as soon as we select only one, we can also select one word from the right-hand side or from the right of the word, and then go eventually add the word to both similar suffix and prefix sets separately. So here, I can first reverse the word to keep it here is equal -1. So here, this is the reverse version of the word itself, and then self.suffix rw reverse word of until j that add the word. So these two are two different dictionaries that here in the first one, we're storing all words for a given key. This is a set of all words having the same prefixes with the key. And likewise, in suffix, this is another dictionary for a given key. It is referring to a set of words that ends with the suffix equals to the key. The only thing that we are missing here is that here, as we are iterating through the words, there is one missing because for an empty character, we have that, but the word itself is the prefix of itself and vice versa. As for example, a should be prefix of a itself and is a suffix of itself as well. So I increase this index by 1 so that we create a new prefix and suffix sets so that we add the word itself, the whole word, into those sets as well. Now, the second part, given a prefix and suffix, we can quickly find those sets. This is the first set is self.prefix of prefix. This is, now we have a set of all words having the prefix as equal to prefix. And likewise, we can get the second set as the suffix of key suffix. So now the second one is a set of all words ends with suffix. Now now that we have sets, we can compute the intersection of these two sets very quickly. And if you don't know the time complexity of, let's say we have two sets in Python, one of them of size n and the other one of size m, we can compute the intersection of those two sets in the minimum of the minimum of n or m. So here I brought some description. I can put this link in the description. That's the time complexity of that compute defines why it is equal to the minimum of m and n. But simply, first it finds the shortest one, or the one that has smaller items first, and then as we know that for a set, in order to check if an item exists in a set, it's an O1 because it is using a hash and can quickly check if an item exists in a set or not. So just simply iterate through the smaller set and then create a new collection or create a new set of all items that repeats in both sets. So this is how we can find the S1 and S2. This is the intersection of those two sets. So intersection equals this set and this set. So we no longer need these S1 and S2. So let's say first we need to return the indices. If it doesn't, the intersection of these two sets are empty, we should return -1. So if the length of intersect less than 1, return -1. Otherwise, we have the word. So we should find the word that has the largest index. So now we have a set of words and we need to find the maximum index. But the problem is we haven't stored the indices in our data structure yet. So here, when we are creating our data structure, instead of iterating through the words, we can define another dictionary. So self-index or indices equal dictionary. And then instead of word, I can say index and w in enumerate. So now we have the index as well. So everything is the same, but we should store the index for each word separately so that given a word, we can, in O1, we can quickly access the initial index of that word in the given list. So self.indices of w equal index. Now we have the index as well. Now we are given a set of words in this set and we should return the maximum index. This is as simple as that. So we can create a for loop, initialize with -1, and then iterate through all words and find the maximum. But what I like quickly is we can simply in using a max function, the maximum of self indices of W for W in this intersection. So this max function iterates through all words in the intersection, and we are using the index and find the maximum of indexes of all words in this intersection set. And if I run that, so let's find the issue here. The problem is we reverse each word when we were creating the data structure here, but given the suffix, we should reverse this suffix in order to locate all words ending with that suffix. But here, the suffix is not reversed, and it is simply the end of each word. So for example, in the Apple example, so let's say the prefix is AP and then the suffix is LE. In our data structure, we added Apple to EL, but the query is LE. So similarly, we should reverse the suffix here as well by using this. So now the query suffix is reversed, and then we are locating that using self.suffix of this reversed query. We run that again. Okay, so it should be fine. Let's run that. All right, so we could run that in 897 milliseconds using the 3 different dictionaries, 2 of them default dict of set, and the other one for storing the indexes without necessarily having to store the list of the words in our data structure. And the task was to maximize this function performance only. So that was everything for this video.